Alright folks, we have 2 days where we are revisiting square roots. So we want to start today by reviewing simplifying square root expressions, and we will then throw in some variables inside of them. So the first part of the lesson is going to be to review simplifying square root expressions. I'm going to do number 1 with you. You guys should be able to handle numbers 2 through 6 on your own. Remember, the main thing we did here when we were simplifying radicals was take the factor trees, so what multiplies to give me 75. You can come up with any two numbers. First things that pop into my head are 3 and 25. I want to be able to write these so that I know as I multiply across, I'm always going to get back to the number inside. 3 times 25 is 75. Factor tree, again, because these are not both prime. 3 is, but I'm still going to bring it down. 25 is not prime, it's 5 times 5. Just like before, I'm going to check my work. I know that if I multiply straight across 3 times 5 times 5, I get 75. That's a way for me to check to make sure I have every single one of my factors. They're all prime, I have all my factors. Now is when I look for pairs. A pair of 5s means I'm going to use one and not use the other, because the square root of 5 times 5 is 5. The pairs are what I pull out. I have one pair of 5s, I pull one 5 out. I have one 3 left over, it's no pair, it stays inside. If I have multiple things I'm pulling out, you multiply them together and pull it out front. If you have multiple things that are staying in, multiply those together and keep them inside. At this point, I want you to go ahead and press pause. Try numbers 2 through 6. When you're done with those, go ahead and unpause to check your answers. Make sure you show your steps. Try not to lose any of your prime factors, and show me your simplified answer. There should be all exact answers, no decimals. Alright, to start, here's our answers for 2 and 3. For number 2, we had a pair of 3s with another 3 left over. The pair of 3s, I pulled one of them out. 2 was left over, wasn't used. 3 was left over, not used. If it's not used, I multiply them together, put them back inside. For number 3, I had the negative sign out in front. I keep that negative. I multiply that negative by whatever is coming out in front. That was a 2, so it's negative times 2 is negative 2, with a square root of 2 left over. If you haven't finished 4 through 6, pause now and go ahead and do that, please. And for 4 through 6, we had 3 square root 2, negative 3 square root 5, and number 6 can't be simplified because I have that negative inside the radical, and there's nothing that'll multiply by itself and be a negative number. So the new thing for today is on our next page, and that's square roots or radicals with variables. What we need to recall first and foremost is what are variables. So if I give you z to the 4th, I want you to recognize that that's z times z times z times z. Z times itself 4 times. Therefore, if I'm taking the square root of that, that's the same as saying square root of z times z times z times z. Z to the 4th, 4 z's, all inside my square root. I can treat that just like my prime factors in my factor tree. Anytime I have a pair, I can pull one out. I have a pair of z's here. I can pull one of these out, get rid of the other. Pair of z's, I can pull one of these out, get rid of the other. So what am I pulling out? Z times z. What is z times z? Z squared. Let me draw your attention to this expression here with what's left in, or what was started inside. I want you to notice that your exponent is exactly half. That's not a coincidence. Since this is all talking about pulling out pairs, if you have an even exponent inside your radical, you can cut it in half, and that's how many pairs of that variable you have. So at the end of the day, when I'm simplifying with radicals, I can do this in one of two ways. I can use my factor trees, or I know x to the ninth I could do and work just like I had up here and say, well, that's the square root of x times 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 x. And just pull out pairs, because that's 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. There's one pair I'd pull out, two pairs I'd pull out, 3, 4 pairs I'd pull out, but I'd have an x left over. Well, if I have 4 pairs, that's x times x times x times x, x to the fourth. That comes out. What's left over is just my x. Or I can use my rule of even exponents like I just mentioned. If your exponent is even, you can cut it in half. X to the ninth does not have an even exponent though. I can rewrite that as x to the eighth, go 1 down, times x to the first. Recall your exponent properties. That's the same as x to the ninth. X to the eighth is an even exponent. Cut it in half, I get x to the fourth. That goes and gets pulled out. X to the first is an odd exponent. That x stays inside. I get the same answer. One just requires a little bit less work. And I'm fine with you doing whichever method you choose. Let's try 3 of these together, and then I'll have you branch off and try the bottom 3 on your own. For number 1, I have g to the 11th. 11 is odd. To write it as an even exponent, I make it g to the 10th times g to the first, because that's the same as g to the 11th. That's all inside my square root still. What's nice is I now have my even exponent here. I know that if I have 10 g's, I have 5 pairs of g. That gets pulled out here. That's just 1 g that's left over. It doesn't have a pair. It stays inside. And I'm done. It works the same if I have 2 variables. I just have to look at them completely separately. Each variable is its own problem. Since I have x to the 8th, I know I have the square root of x. It's even. Keep it. Don't change it. But y to the 5th is odd. Change it to 4 and 1. Now I have 2 variables with even exponents. This is an even x to the 8th. That gets pulled out and made x to the 4th. This is an even y to the 4th. That gets pulled out and made y to the 2nd. I cut my exponents in half. Since y to the 1st is left over, no pair, it stays inside. I can put the exponent of 1 if I want, or not. I don't have to. And number 3 is our third type that we have to be concerned about, and that's when I have a coefficient variable. The number we treat the same. If you want, a lot of times it's easier for students to do it this way. Take a look at square root of 20, and separately take a look at square root of x to the 3rd, y to the 14th. Simplify your or your coefficient, your 20, the same way that you always have. That's 4 times 5, which is 2 times 2 times 5. That's a pair of 2's, so you use one and get rid of the other. What I would just say is, when you go and write down your 2 root 5, leave yourself room. Because you know you have variables, and something's going to happen with those, and you might need to pull some of them out. For this, treat your variables like we had before. X to the 3rd becomes x to the 2nd times x to the 1st. But y to the 14th is already even, it stays. So, x to the 2nd is even, I pull that guy out, cut it in half. X to the 2nd divided by 2 is x to the 1st, or just x. Y to the 14th is even. I pull even ones out by cutting it in half. Half of 14 is 7. I get y to the 7th. X to the 1st was left over. X stays inside. There's my simplified radical. If that stuff was too fast or too confusing, rewind, go back and watch it again. See if you can pick up on exactly what we were doing. Then try numbers 4 through 6. When you're all done, unpause to check your answers. So I haven't shown all of my work here, but I have shown what my factors would be when I was ready to go and pull these out. 25 is 5 times 5. Pull a 5 out, get rid of a 5. G to the 16th, half of that is G to the 8th, it gets pulled out. H to the 9th, I had an odd exponent, made it 8 plus 1. Pulled out my 4 H's, left 1 in. I didn't factor tree 72 all the way down because I knew it was 2 times 36 and 6 was 6 times 6. I had a pair, that's all I need. I pull that 6 out, this 2 goes back in. P was already even, I cut it in half and pull it out. Q, instead of 7 I made 6 plus 1. Pulled half of my 6 out, left my 1 in. Again, if you have questions or you're still confused, go back and re-watch parts of the video. At this point, you could go ahead and try your Canvas quiz if you feel like you're ready.